Hi everyone, welcome to Coadep Econs Academy. The Academy helps you to sharpen your skills in solving pertinent questions in economics. Our lessons are useful for those at the advanced, intermediate and lower levels. Today, we're going to engage ourselves with the production possibility frontier. The lessons are in 3 parts. The first part, we are going to deal with curves, and this lesson is going to be useful for those at the lower and intermediate levels of the study. What we have is a production possibility frontier, and we are going to use it to answer different types of questions. On the PPF, we have computers on the vertical axis and TV on the horizontal axis. And what it means is that we are using all available resources at the given technology to produce different combinations of the two commodities. Now, the curve, which is the production possibility frontier, is the maximum combinations that are possible for us to produce with the given resources and the technology at our disposal. This means that any combination above the PPF is not attainable with the given resource and the technology at our disposal. Below the PPF, we have infinite combinations of the two commodities that we can produce. But when we produce within the PPF, our production is inefficient because at any point we can increase production of one of the commodities without reducing any of the other commodities. This is the basic concept we have to keep in mind as we move on to go through the questions. We will need to tell the type of opportunity cost shown. We will be given quantities of production and we will identify the associated opportunity cost. We will also look at where we change one option for the other and look at the associated opportunity cost. We are also going to be given certain production options, and our duty will be to determine whether the options are efficient or not. We are going to examine shifts in the PPF and factors that are responsible. So let's start. In question 1, our duty is to determine the type of opportunity cost exhibited by the PPF. Let's consider television sets. We are producing the maximum of television sets, which is 100. And to do that, we are not going to produce any computers. Now, when we decide to move to point B, that means that we want to produce 8 units of computers. By so doing, we have to give up 10 units of TV sets to produce 90 units of TV sets. Now, let's consider what will happen when we move from B to C. By moving from B to C, we are going to increase the production of computers from 8 to 14. But before we can do that, we have to reduce TV from 90 to 70. That means we have sacrificed 20. And this clearly tells us that opportunity cost is increasing. From A to B, 10 TV has to be sacrificed. B to C, 20 TV has to be sacrificed. So opportunity cost is increasing. Now as we move further to D, we are going to produce 18 units of computers. But at D, TV sets are going to reduce to 40. And again, we are moving from 70 to 40, sacrificing 30 units of TV, which is again an increase in the opportunity cost. Finally, as we move from D to E, we have to give up all the 40 sets of TV before we can produce the maximum of 20 computers. So as we move from A to E, we see that opportunity cost in terms of TV is increasing. The reverse is true. So the point that we have to keep in mind is that whenever the production possibility frontier is concave to the origin, so when you observe from the origin, you see that the curve is concave. It means that opportunity cost is increasing. So answer to question 1 is that the PPF exhibits increasing opportunity cost. In question 2, we are producing 90 pieces of TV. So what is associated opportunity cost? Alright. Without producing any TV, we can produce as many as 20 computers. By deciding to produce 90 TV sets, we can produce only 8 computers. So the difference will tell us the sacrifice that we are making in terms of computers, and that is the opportunity cost. So when we take the difference, we see that for us to be able to produce 90 units of TV, we have to forgo 12 units of computers. So the opportunity cost of producing 90 pieces of TV is 12 pieces of computers. B. Find the opportunity cost per unit when 90 pieces of TV is produced. We are going to distribute the opportunity cost for the units that have been produced. So let's take notice that when we produce 90 pieces of TV, the opportunity cost is 12 pieces of computers. Therefore, we have to divide the 12 by 90, and that will mean that we are spreading the cost for the units produced. By doing so, we are going to get 0.133 piece of computer, and that is the opportunity cost per unit when we produce 90 pieces of TV. In question 3, we are producing 20 pieces of computers. And what is the associated opportunity cost? Alright. Because we are producing computers, the opportunity cost is going to fall on TV. Now, if we don't produce any computers at all, we can produce 100 pieces of TV. Producing 20 units of computers, we cannot produce any unit of TV. That means that the difference is the number of TV we are foregoing. So when we take the difference, we are foregoing 100 pieces of TV in order to produce 20 units of computers. Therefore, the opportunity cost of producing 20 pieces of computers is 100 pieces of TV. Now, in question 4, we are changing our option. So we are already at C, and we are now moving to B. So what is the opportunity cost? At C, we have 70 units of TV. When we move to B, we have 90 units of TV. So when we change our option in this manner, we are going to get more of TV. So there's no opportunity cost in terms of TV. But let's look at what happens to computers. At option C, we have 14 pieces of computers. When we move to option B, the units of computers decrease to 8. That means that when we change our option from C to B, we are going to have some cost in terms of computers. So at point C, we have 14. As we move to point B, we have 8 units of computers. The difference is the opportunity cost. So by moving from C to B, we have to forgo 6 pieces of computers. Therefore, the opportunity cost of changing from C to B is 6 pieces of computers. Now, we want to spread this opportunity cost per unit of the output. We decide to move from C to B. How do we see? We are losing these quantities of computers, and we have to spread it over the gains that we are going to make in TV. So we are at 70, we move to 90, so the difference is the gain for TV. We are at 14, we come to 8, the difference is the loss in computers. And when we do the division, we are going to get the opportunity cost associated with that change in option. The difference 6 for computers, so we are losing 6 computers and we are gaining 20 TV. So per unit, we have 0.3 piece of computer being the opportunity cost. So the opportunity cost per unit, that is associated with changing option C for B, is 0.3 piece of computer. In point 5, we have been given a production option. We are producing 60 pieces of TV and 10 pieces of computers. So how do we consider this? Is it efficient? Is it attainable? Let's go to the PPF. So we are producing 60 TV against 10 computers. So 60 against 10 will be this point. So 60 TV, 10 computers is this point. And clearly the point is within or below the PPF. And that means that it is inefficient. With the available resource and technology, we can maintain our 60 units of TV, for example, and go up here to increase the quantities of computers beyond 16. Or we can maintain the 10 units of computers and still with the given resource and technology, we can increase TV to this point, which is about 85. That means that when we produce at this point, we are not being efficient. Therefore, a production option of 60 pieces of TV and 10 pieces of computers is considered as inefficient. What about the option of producing 50 pieces of TV and 90 pieces of computers? Now, 50 pieces of TV is here and 19 pieces. So TV 50 pieces is here and 19 pieces of computers. This is 19. So the point will be here. 50 against 19 is here. Clearly this point is beyond the PPF. That means that we cannot produce this point with the given resource and technology. So this option is unattainable, it is not realistic, it is not feasible. So a production option of 50 pieces of TV and 19 pieces of computers is considered as unattainable, not feasible, and not realistic. Now, a rightward and outward shift of the PPF signifies what? We should also find out factors that are responsible for a rightward and outward shift of the PPF. Now, whenever the PPF shifts outward, it means that we can produce more of both commodities. So, shifting outward means that it's going to be within the region which we have considered as unattainable. So if the PPF shifts outward, certain combinations that were not attainable will now be attainable. In other words, we can produce more of each commodity, and that signifies economic growth. So a rightward and outward shift of the PPF signifies economic growth. Now, what factors can cause this rightward and outward shift? Remember, we said that technology was given, so any improvement in technology will shift the PPF outward. We said resources are fixed. Any discovery of resources will shift out the PPF. Again, when we are able to increase active labor force, or in general terms, increase in population can result in outward shift of the PPF. Also, positive net investment in capital can result in outward shift of the PPF. In question 8, we want to examine the factors that cause inward shift of the PPF. Inward shift of the PPF. Now, when we have inward shift of the PPF, that signifies a shrink in the economy. Inward shift of the PPF can result from negative net investment in capital, natural disasters, war, running out of resources. Some resources are non-renewable. So when they are run out, the PPF shifts inwards. Thank you for watching. Please do subscribe, like, and share to support the channel.